Okay, guys, so we're back again. Again, a lot of technical issues on my end. There's a storm going on outside, which cut out the power just a little bit ago, and then the power from my phone went. The internet from my phone broke as well for some reason. I don't know why, but now I'm back. Now I'm connected to Wi-Fi again. Which cut out the power just a little bit ago, and then my power from my the power from my phone went the internet from my phone broke as well for some reason. I don't know why. Okay, guys, so back to explaining. My bad for all the technical issues right now, guys. I don't have any control over them. My bad for all the technical issues. So now we are yeah, where were we? So we have, let's say, first we have this. So why does sorting work here? Well, here's why. So approach sort both arrays and add or subtract where numbers differ until they are the same. Okay, guys, and we're gonna and on each operation increment answer. Okay, so this is the approach right here. So why does this work? Well, we have our arrays of seats and students. Let's sort them. So seats becomes, after sorting, it becomes 1, 3, and 5. And students, after sorting, becomes 2, 4, and 7. So where do these arrays differ? So we have 1, 3, and 5, and then we have 2, 4, and 7. Basically, we just put these arrays, like, we can look at them like this. We can look at the arrays like this, and basically we are just going to increment. So if this is less than this, we're going to increment it while it's not. So here we're going to increment 1 by 1. That's going to give us 2. That's 1 move. Here the difference between these two is 1. We're going to increment 3 by 1. That's 2 moves. And finally we're going to increment this by 2, which is also 2 moves. And as we can see, that is our answer. That is 4 moves. That is why we sort these here. And here we have this for loop, which goes through and as we can see, the length of the both arrays is the same length. This is why we can do this. So as we can see, if students of I is greater than seats of I, while this is true, while students of I is greater than seats of I, we're going to decrement students of I. Okay, and we're going to add an answer. We're going to increment our answer. Else, if students of I is less than seats of I, which is the case in our case, then we're going to increment students of I until it is not less than seats of I. Then we're going to do answer plus plus. Okay, so that is the first example. So yeah, and that, guys, is basically how that one works. Okay, again, guys, my bad for the 3 separate streams, but I'm facing some technical issues. There's a storm, the power just went out, and then my phone messed up the internet, so now I'm connected to Wi-Fi again. Hopefully nothing happens again. Okay, guys, so okay, so let's do the second example. Then let's do the second example, so this becomes clearer for you guys. So in case 2, so in case 2, we have seats, and then we have students again. So we're going to sort seats, and we're going to sort students as well. Okay, and then afterwards we're going to get 1 4 4 5 9 and 1 2 3 6. Okay, so our moves is going to be equal to 0 initially, and then we see that 1 and 1 we don't need to do any moves right here. Then we have 4 and 2, so we can either decrement 4 by 2, or we can increment 2 by 2, and this is, in both cases, this is gonna give us 2. So this, it becomes 2. Then we have 5 and 3, so we need to perform 2 moves here. So this is gonna become 4 now. And finally we have 9 and 6, so we either decrement 9 by 6, we either decrement 9 by 3, or we increment 6 by 3 times, and then this is gonna give us 7. So this is the answer for the second one. Okay, this is the answer for the second one. All right. And yeah, should we go over the third one? So actually, what am I checking? If students of I is greater than seats of I, then if seats of I is greater than students of I. So in this case, increment. So we actually know. We only increment or decrement the students. We don't, guys, my bad. We don't decrement the seats. We don't decrement or increment the seats. We only increment or decrement the students. So as we can see, we decrease the students or we increment the students. Okay? Yeah. We don't touch the seats. Because increase, yeah, we have here increase or decrease the position of the ith student by 1. So guys, we do not, my bad, we do not decrease we do not increase or decrease the seats. We only increase or decrease the students. Okay, as we can see here in the code. So basically, to correct myself, the students is this. So here we're not gonna increment or decrement. Here we're going to increment by 2, which is 2. Here we're going to increment by 2, which is another 2. Here we're going to increment by 3, which is 3, and that's in total gives us 7. Okay, and let's go to the last case as well. Let's go to the last case as well. Something like this. So we have case 3, which is this. So we have the seats and the students. So we're gonna sort the seats and we're gonna sort the students. Okay. Okay. And then, so basically we're gonna have 2, 2, 6, 6. Then we're gonna have 1, 2, 3, 6. Okay, so, and then we're gonna have the moves, which first is gonna be 1 move because we need to increment 1 by 1 to get 2. Then it's 0, that's 1 plus 0. Then it's 3, so that's 4, and then it's 0 again, so that's 4. And as we can see, we get here 1 plus 3 plus 0 plus 0. That is 4, and that is how we get the answer for the third case as well. We can submit this again, as we can also, and it should pass. Again, memory pretty good, B63. Runtime not as good. Again, guys, I am not always showing the most optimal solution. I'm just showing how I have been able to solve it. Okay. All right. Okay, guys. So That's it for that one. Okay, and then we're gonna mark this one as done. So I mean, in total, we have already been streaming for about an hour. We have like about 15 more minutes, so we'll see how far we can get. So next problem is Code Forces 88 Panoramics' prediction. That is the next problem. Okay, so let me update this. So current problem is Code Forces. Oops. Okay, I'm gonna Code Forces 80A. This is 80. I'm just gonna say 80A for now. Okay. Panoramics prediction or something. I think. Yeah, okay. So this is the next problem. It's a Code Forces problem. So let me open it. Okay, and this one you need to know about prime numbers. You need to know about prime numbers to solve this one. Okay, so here's the statement. Maybe I'm gonna zoom in a bit so it's bigger. Okay, something like that, or maybe something like that. Okay, a prime number is a number which has exactly two distinct divisors, one and itself. For example, prime numbers are 273 and 164 are not. The next prime number after x is the smallest prime number greater than x. For example, the next prime number after 2 is 3, and the next prime number after 3 is 5. Note that there is exactly one next prime number after each number, so 5 is not the next prime number for 2. Okay. One cold April morning, Panoramix predicted that soon Cacophonics will break free from his straitjacket, and this will be a black day for the residents of the Gallic countryside. Panoramix's prophecy tells that if someday Asterix and Obelix beat exactly X Roman soldiers, where X is a prime number, and the next day they beat Y Roman soldiers, where Y is the next prime number after X, then it's time to wait for Armageddon, for nothing can shut Cacophonics up while he sings his infernal song. Yesterday the Gauls beat N's Roman soldiers, and it turned out that the number N was prime. Today their victims were a troop of M Roman soldiers, where M is greater than N. So it really is the next one. Determine whether the Gauls should wait for the Black Day or after today's victory of Asterix and Obelix. So basically we get two numbers, and we need to figure out if M is the next prime number after N. So the first line of the input contains only two numbers, N and M. Okay, two positive integers. It's guaranteed that N is prime. Pretests contain all the test cases with restrictions these. Print yes if M is the next prime number, or N or no otherwise. So guys, in order to solve this, you need to know how to generate prime numbers in a range. So right here the range is pretty small. It's only from 2 to 50. So what I have done is I have generated all the prime numbers from 2 to 50, and then basically I have checked if the next prime number after N, if M is the next prime number in the array after N. Okay, so yeah, let me I'm gonna open up the code right here. So panner, there it is. Okay, so yeah, you guys should know. So to check if a number is prime, basically a prime number is divisible only by 1 in itself. and this is how we check if a number is prime. So basically, if that number is divisible by anything starting from 2 up until that number, up until square root of this number, that means it's not a prime number. Also, right here, I have not taken into the account that this case where the number is 1, because 1 is not a prime number. Okay, 1 is not a prime number. I have not taken that into account, but for this problem, you do not need to. So basically, I have generated all the prime numbers from 2 to 50 inclusive, since this is what m can be and n can be. And I have made an array of called primes, which stores these prime numbers. And then I get the input n and m. Then if, oops, no, not this one. So if primes of I is equal to n, so if we have found n, then I'm setting the index, the n index to I. Okay, and then this is an edge case. So for example, the index, so the prime number, for example, can be like 47 or something, and this is going to be the last index pretty much in the array. And then there is no prime number after the last prime number in the array. So that is why I have checked this edge case, because if I had not checked this edge case, I would have been out of bounds of the array. So if this is the test case, then we print no. Then if not, we get the next prime number, which we have an array of prime numbers. So that is going to be the index of the prime number of n plus 1. And then if m is equal to the next prime numbers in the array, we're gonna print yes. Otherwise, we're gonna print no. Don't worry, we're gonna see the code in action. We're gonna see the code in action right now. So let me just open this. So yeah, I'm going to see out for auto x in primes. I'm just gonna see out x. Okay, and then a new line. All right, so these are all the prime numbers from 2 to 50. So basically, if we get 47 as n, that means that there is no next prime number, so it's gonna return false. It's gonna get no. So let's say we get 3 and 5, we get yes, because as we can see, 3, the position of this is 3, and after 3 in the array is 5, so we get yes. Okay, so let's check the second case. The second case is 7 and 11. As we can see, we get yes again, because 11 comes right after 7, because 11 is the next prime number after 7. And then finally, for the final test case, where we're not gonna get yes, because 9 is not a prime number. 9 is not a prime number, and it is not present in the array. And so the next number after 7 is 11. That means it's not 9. Also, 9 is not prime. And so we're gonna get no as the answer. Okay, and that is basically it for that one. Keep going, man. Thank you so much, M77, not Max. Thank you so much. I will keep going. Thank you so much for the support, bro. Okay, so that's it for that one. That's it for that one, and I think we're gonna go over one more, and then that's gonna be it. So this is gonna be the last one for today. Studying out code forces, studying algorithms. So this one is a greedy. This one is a okay. There's no tags, but this one is a greedy question. So Basically, Steph wants to improve her knowledge of algorithms over winter break. She has a total of X minutes to dedicate to learning algorithms. There are N, about is most 100 algorithms, and each one of them requires A of I minutes to learn. Find the maximum number of algorithms she can learn. So the maximum is 15 right here, and these are all the how much it takes to learn each algorithm. So basically, again, this is solved by sorting this array and basically just adding to some sort of total and to a counter while the total is less than equal to this the x. So if we look at the code, it should be, I'll go, there it is. So if we see the code is pretty simple, we just, so in greedy questions and greedy problems, we often need to use sorting, as I already mentioned in one of the previous problems. So what we do is we get all of the elements, we get all the data first, we get our array, then we sort the array, and then we have the answer and the total. And for each element in the array, if adding that element to the total is less than or equal to x, we are going to increment the answer by 1, and we're going to add to the total so we can stop when it gets over x. So yeah, let me show you guys this in here. Let me do this. So current problem is code forces. Okay, this up. So current problem is code forces. Oh, okay. I'm gonna have to do that again. Current problem is studying code forces whatever this one. Okay, so we get 6 numbers. So n is equal to 6, x is equal to 15, and then we have these ones, then we have these numbers. So there, and so this is our array, and then we're gonna sort it. We're gonna sort the array just how we did in one of the previous questions, and then it's gonna become 3, 3, 4, 4, 7, 8, 7, 8, and then we're going to keep track of a total, which is 0, and an answer, which is 0. And then on each iteration, while the total is less than or equal to 15, we're gonna keep adding to the total and incrementing the answer. So total plus 3 is less than or equal to 15, so we're gonna increment the answer. So now the answer is 1. Then total plus 3 again is gonna become 6. It's also less than or equal to 15, so we increment the answer. Now the answer is 2. Then plus 4, it becomes 10. So we increment the answer again, and then it is 3. Then finally, this is the final one we can add. So we increment the answer again. The total again becomes 14. And we increment answer, and it becomes 4. Now, if we add 7, it's not less than or equal to 15 anymore. So we have yo, what's up, man? So it's finally, so yeah, we stop at counting after 4, and that is basically how that works. All right. Okay, guys. Thank you so much for everybody who tuned in again, who tuned in today. Make sure to like, comment, subscribe. Thank you so much, and I'll see you guys